Oh, I've been working on the railroad all the live long day. Hi there! Hi. Dr. James N. Nuclear here for Whalebone IR, where the future is only 2 days away. Cameraman's always starting his videos a little bit early. I was just working on the skylight here. In my last video, I didn't kind of like the way it was like, beam me up, Scotty. Woo! That sticks, though. So anyway, welcome in. Today, we're going to talk about actual Algebra 1 math standards. That's right. The Whalebone IR system has graduated from simply presenting how to work with the system to actually working with mathematics. And we're going to, if you follow me down, excuse me, down, come on, down. That's it. Hi. As I said, we're going to work with the, we're going to work with the step stool first. But we're going to work with California Algebra 1 standards. This might get a little boring. I'm sorry about that. I'm going to have to go over a lot of technical words and a lot of subsets of numbers in mathematics. Bear with me. If you get lost, if I go a little bit too fast, guess what? It's a video. Hit the rewind button. Listen to it over and over again. Play it in your car. You'll be fine. Trust me on this. It is important that we learn these particular words for things so that we can talk to each other at a higher level. Know what I mean? So, first I'm going to present the standard as it is read right from the text. Algebra 1 Standard 1.0. Students identify and use the arithmetic properties of subsets of integers and rational, irrational, and real numbers, including the closure properties for the 4 basic arithmetic operations where applicable. Furthermore, 1.1. Students use properties of numbers to demonstrate whether assertions are true or false. Big words, huh? Forgive me if you're new to the English language, and I know a lot of you out there are. But we need to use big words because big words zero in right on the meaning that we're trying to get. I'll try to break this down for you a little bit. Students identify and use arithmetic properties. Arithmetic is just an adjective for arithmetic or math. Math properties. A property, that's the plural of property. That is to say, the quality, the aspect of it. Subsets of integers. That means there's different kinds of numbers. There's a big set, and then there's a subset. Big set, a subset is a smaller set that fits inside of a bigger set. So we have subsets of integers, rational and irrational, real numbers, including the closure properties that are the 4 basic arithmetic operations. The 4 basic arithmetic operations are these: addition, subtraction, multiplication, and division. Got it? The 4 basic arithmetic properties. Arithmetic like arithmetic. The 4 basic math properties or operations. They are adding, subtracting, multiplying, and dividing. That's what we're talking about when we say the 4 basic mathematic operations. And the closure property, woo, that's a big college concept. Closure means exactly this. That when you are inside of this big set of numbers, you can move all around inside of it. You can add, you can subtract, you can divide, you can multiply, and you'll never get out of the bigger set. In other words, if I take 5 and 10 and I add them together, I get 15. 15 is also included in the larger set of numbers. So it's like I'm closed in. I can't get out. It's the closure property of these operations. If you can add, subtract, multiply, divide, you can try whatever you want. Doesn't matter. You can't get out of the larger set of numbers. You're closed in. That's a closure property. Okay? That's enough of this for now. And we'll have a little quiz that will cover this thing. This part's easy. But now I want to go into more detail about what these words mean. What is an integer? What is a rational number? What is an irrational number? And what makes up a real number? Okay? We're going to move to a PowerPoint presentation here. Now, to understand the different sets and subsets of numbers, we have to talk about the history of numbers. And I mean way back history. We're talking Grog the caveman history. You know what I'm saying? You know? Back in the very, very beginning of humanity, when people first started to need to count things. So, when they're getting their rocks ready to go out on a hunt, or their spears, they want to make sure they had enough of them. So Grog's in the cave going,
we got enough rocks. How many rocks you got? I don't know. How many rocks you got? Let's count them.
So they developed a system for counting. Very quickly they were able to go,
1 rock, 2 rock, 3 rock, 4 rock. I got 4 rock. How many you got?
Other caveman, I guess his name was Doug or something, he said,
I got 1, 2, 3, 4, 5, 6. 6 rocks. Me got more rock than you got. Ha ha ha. That's okay. I aim them better. Ha ha ha.
And they both had a good time. Point was, they had a number system that was okay for their needs. It started at 1, it went to 2, 3, 4, and onwards and etc. However many sheep they had, however many rocks they had, however many bushels of wheat they had, they could count them. And this was a very natural system. This became known as the natural numbers, or counting numbers. The natural numbers. So in math we give that a name. Notice here, example, 1, 2, 3, dot, dot, dot. The dot, dot, dot means that this set of numbers keeps on going forever and ever. You can keep on counting forever and ever and ever if you want to in our system. And it will still be called a natural number. Notice one thing though. Grog and his buddy Doug had no need for the number 0. The number 0 is over here, separate from the natural numbers. Number 0 didn't come along until later. They figured, you know, if there's nothing to count, why invent a number about it? Okay? Stupid. But they were cavemen. Later on, we did come up with a need to use 0, especially as a placeholder and multiplying by 10. So, we had a new system of numbers come about. Brilliant invention. Whoa! Take the counting numbers, add a 0 to the beginning of them. What do you get? You get a number system called the whole numbers. Examples of the whole numbers is 0, 1, 2, and 3. So this is just the natural numbers, all of them, plus tack on a 0 to the front. Now, natural numbers and whole numbers together, I want you to notice something. I have drawn this diagram, it's called a Venn diagram, to demonstrate that the natural numbers are completely contained within the whole numbers. So, anything that is a natural number is automatically, because the circle goes all the way around it, anything that's in the natural number circle is also in the whole number circle. So anything that's a natural number is also a whole number. Got it? Good. Moving on. We have a situation came up. We invented submarines. Or we started to measure temperatures. And we invented these, we had these existing scales of numbers that started at 0. Like 0 degrees Fahrenheit, which is very, very cold. But lo and behold, somebody came up with something that was colder than 0. What to do? How do we represent it being colder than 0? If 0 is already nothing, how do we go below nothing?